the electrical circuit begins at the overcurrent protective device, or OCPD. Therefore, the circuit would include the OCPD, the conductor, and the receptacle. The question then arises, is using a number 10 conductor on a 20-amp breaker a violation of the National Electrical Code, or NEC? The answer is no. It is not a violation as long as the conductor is properly protected by the OCPD. In this instance, the OCPD is the 20-amp breaker. Let's delve into the specifics of the NEC to understand why this is permitted. NEC Section 210.3 is crucial. It states that conductors and equipment shall be protected from overcurrent in accordance with their ampacities as specified in Section 310.15 by either circuit breakers or fuses. This means that the conductors must be protected by an overcurrent device, such as a circuit breaker or fuse, and the rating of the overcurrent device must be appropriate for the ampacity of the conductor. Next, we need to examine NEC Section 310.15b16, which addresses conductor ampacity. This section states that conductors rated 10 American wire gauge, or OG, or larger shall be protected by overcurrent protective devices having a rating not exceeding the conductor ampacity. In the example given, a number 10 conductor is protected by a 20-amp breaker. It's essential to determine if the 20-amp breaker exceeds the ampacity of the number 10 conductor. According to NEC tables, a number 10 copper conductor typically has an ampacity of 30 amps when used in typical wiring installations at 60 degrees Celsius termination rating. Since the 20-amp breaker is less than the 30-amp ampacity of the number 10 conductor, the conductor is adequately protected. Therefore, there is no violation of the NEC. It is vital to consult the specific ampacity tables within the NEC, as ampacity can vary based on factors like conductor material, insulation type, and installation conditions. For instance, the ambient temperature and the number of current-carrying conductors in a raceway can affect the allowable ampacity of a conductor. Dating factors may need to be applied in certain situations to ensure that the conductor's temperature rating is not exceeded. The purpose of these requirements is to prevent conductors from overheating, which can lead to insulation damage and potentially cause fires. Overcurrent protection devices like circuit breakers and fuses are designed to trip or blow when the current exceeds the conductor's ampacity, thus protecting the conductor from damage. In summary, using a number 10 conductor on a 20-amp breaker is permissible under the NEC, provided that the breaker adequately protects the conductor from overcurrent. This is because the ampacity of the number 10 conductor is greater than the rating of the 20-amp breaker. Always refer to the NEC and consult with a qualified electrician to ensure compliance with all applicable electrical codes and standards. Remember that electrical work can be dangerous, and it's essential to take all necessary safety precautions to prevent injury or property damage. The NEC is a comprehensive set of guidelines that aims to ensure the safe installation and operation of electrical systems. It's regularly updated to reflect changes in technology and industry best practices. By following the NEC, electricians and other electrical professionals can help to minimize the risk of electrical hazards and create safer electrical environments. It's also important to note that local codes and regulations may supplement or amend the NEC. Therefore, it's crucial to be aware of and comply with all applicable requirements in the jurisdiction where the electrical work is being performed. Firstly, always consult the most recent edition of the NEC to ensure that you are using the most up-to-date information. Secondly, pay close attention to the specific requirements for conductor ampacity, overcurrent protection, and other related topics. Thirdly, seek guidance from a qualified electrician or electrical inspector if you have any questions or concerns about the proper installation or operation of electrical systems. Remember that safety is paramount when working with electricity. By following these guidelines and taking appropriate precautions, you can help to ensure that your electrical work is performed safely and in compliance with all applicable codes and standards. Let's consider another example to further illustrate the principles discussed earlier. Suppose a situation where a 15-amp receptacle is needed on a circuit. The natural choice is to use a 15-amp circuit breaker. However, can a number 12 American wire gauge conductor be used? The answer is yes. A number 12 American wire gauge copper conductor at a 60 degrees Celsius termination rating can carry 20 amps in most wiring applications. The 15 amp receptacle will limit the amount of current going to the conductor to 15 amps, even though the wire can carry 20 amps. Thus, the number 12 conductor is being protected. However, can the number 12 American wire gauge conductor be used on a 20 amp circuit breaker if there is only one 15 amp receptacle in the circuit? No, the circuit breaker must match the receptacle rating. If multiple 15 amp receptacles are on the circuit, a 20 amp circuit breaker is suitable. Keep in mind it is important to know what type of load is on the circuit. If the load is continuous, the overcurrent protection device, or OCT, should be rated for 125% of the continuous load. The remaining capacity can be used for non-continuous loads. In other words, the continuous load cannot exceed 80% of the breaker size. It is also important to know the voltage of the circuit. Circuits rated over 600 volts have different requirements in the NEC. These high voltage circuits are typically used for industrial applications. It is important to note that the NEC is not law unless it is adopted by a local or state jurisdiction. The NEC is a consensus standard that is developed by the National Fire Protection Association, or NFPA. The NEC is updated every 3 years to reflect changes in technology and industry best practices. It is important to consult the latest edition of the NEC to ensure compliance with all applicable electrical codes and standards. The NEC provides minimum requirements for electrical safety. Local jurisdictions may have more stringent requirements. It is important to check with the local jurisdiction to determine the specific requirements for electrical installations in that area. The NEC covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is a comprehensive resource for electrical professionals. The NEC is not a substitute for proper training and experience. Electrical work should only be performed by qualified individuals who have the necessary knowledge and skills. Electrical safety is paramount. Always take appropriate precautions to prevent electrical shock, fires, and other hazards. Before working on any electrical equipment, always turn off the power at the circuit breaker or fuse box. Use a voltage tester to verify that the power is off. Wear appropriate personal protective equipment, such as safety glasses and gloves. Never work on electrical equipment in wet or damp conditions. If you are not comfortable working with electricity, hire a qualified electrician. Electrical work can be dangerous, and it is important to take all necessary precautions to prevent injury or property damage. Regularly inspect electrical equipment for signs of damage or wear. Replace damaged or worn equipment promptly. Do not overload electrical circuits. Overloading circuits can cause overheating and fires. Use extension cords safely. Do not use extension cords as a permanent wiring solution. Do not run extension cords under rugs or furniture. Do not overload extension cords. Keep electrical equipment away from water. Water can conduct electricity and cause electrical shock. Teach children about electrical safety. Supervise children around electrical equipment. Keep electrical outlets covered when not in use. Install ground fault circuit interrupters, or GFCIs, in bathrooms, kitchens, and other wet areas. GFCIs can help to prevent electrical shock. Test GFCIs regularly to ensure that they are working properly. Install arc fault circuit interrupters, or FSIs, in bedrooms and other areas where there is a high risk of fire. FSIs can help to prevent electrical fires. Test FSIs regularly to ensure that they are working properly. Maintain a safe distance from overhead power lines. Overhead power lines can carry high voltages and cause serious injury or death. Call the utility company before digging near underground power lines. Underground power lines can be damaged during excavation, which can cause power outages and other hazards. Be aware of the signs of electrical problems, such as flickering lights, burning smells, and warm outlets. If you notice any of these signs, call a qualified electrician. By following these safety tips, you can help to prevent electrical accidents and create a safer electrical environment. Remember that electrical safety is everyone's responsibility. Take the time to learn about electrical hazards and how to prevent them. Protect yourself and your family from electrical injuries and fires. And always adhere to the NEC and local electrical codes when performing any electrical work.